Okay, so this is our first video. Our first set of videos are all going to be a review of Algebra 1. And in this one we're going to be evaluating expressions, namely algebraic expressions.
Hey all you black cats, welcome to Algebra 2. Alright, dose. Alright, so your objectives for the day, number 1, to evaluate numeric expressions. Number 2, to evaluate algebraic expressions. And then number 3, to simplify algebraic expressions. Simplify. Have a great day.
Okay, in this one we have a lot of review videos. There's going to be review vocabulary. So there's going to be 3 pages of vocabulary. So what I want you to do on each page is I want you to pause the video when you get to the page. So you pause, you write down all the information you need, and then when you're done, restart the video. So vocabulary here, we have constant, variables, numerical expression, and algebraic expression. So pause the video and write down this information, and when you're done, restart the video. So you can go ahead and pause the video now. Alright, this is our second page of vocabulary. So you're going to do the same thing you did before to get the information down. You get it down, then you restart the video. So pause the video now and write down this information. Alright, so this is our last page of vocabulary, and it's about like terms, and I do want you to take special note that I have included here some examples of things that are like terms, and I have included some examples or non-examples here of things that are not like terms. So anytime you see the word non-examples, it's an example of something that in this case is not a like term. So pause the video now, get this information down, and restart when you're done. Our first set of examples in this video, we're just using the order of operations. Remember your PEMDAS. Please excuse my dear Aunt Sally. It's parentheses, exponents, multiplication and division are equal. You work them from left to right. And then finally addition and subtraction, and they are also equal. And you work them from left to right. So first of all, in this first one, you're going to start with your multiplication. So you're going to do 3 plus 2 times 3, which is 6, plus 5. And then you do your addition from left to right. 3 plus 6 is 9, plus 5 is 14. All you're doing here is applying your orders of operations. Alright, in the second problem, we have an exponent. So it's going to come before our subtraction or our multiplication or division. So 15 divided by 3 times 5 minus 4 squared. 4, that means 4 times 4. Exponent tells you how many times to write the base down, and then you do multiplication. So it's going to be minus 16. Alright, then we're going to work on our multiplication and division, which comes next, and we're going to go from left to right. 15 divided by 3 is 5. Then we're going to multiply that by 5, so that gives us 25 minus 16. And lastly, we do our subtraction, so that gives you an answer of 9 there. Alright, our third example has grouping symbols. You work inside your grouping symbols first. So first of all, I'm going to work inside here. 4 plus 3 is 7. So I'm going to do the addition inside there first. And then finally, rest of the problem here. When I have a number here like the 5 and the 2 outside the parentheses, that means multiplication. So multiplication, they're both multiplication, here and here. So those are equal. So what we're going to do is from left to right. 2 times 5 is 10, plus 3 times 7 is 21. So, and then I do my addition, so I get 31. Alright, finally, last problem. It is a fraction. I have a numerator and denominator. What I'm going to do is I'm going to work with the numerator first. So I have 6 plus 4 squared, which is 16. all over 3 squared, which is 9 times 4. So then, once I've gotten rid of my exponents, I'm still working on the numerator. 6 plus 16 is 22. And then the denominator is 36. And then you have to reduce. If they have a common factor, you can factor out. And if you'll notice, 2 goes into 22. 11 times, and 2 goes into 36 8 times, and 11 is prime, so we can't go down any further. So this reduces down to 11 over 18. Okay, here's one I want you to try on your own. Remember, you treat brackets just like they're another set of parentheses, and order of operations, you start with the innermost parentheses and work your way out. So pause the video and work on it on your own now. Alright, so here's what I got for an answer. This simplifies down to 15. If you didn't get this, pause the video and see if you can figure out where you went wrong. If not, we're ready to go on. Alright, now so we're going to be evaluating algebraic expressions. So basically, an algebraic expression is just a numerical expression, except instead of all numbers, you got some variables. And in this case, what we're going to do is just one more step than the numeric expression. First of all, we have to substitute. It says for A, we're going to put in -4, and for B, we're going to plug in 5. So I am going to rewrite everything without my A or my B. My B. And what I'm going to do is I'm going to put parentheses there for A and parentheses for B. And for A, I'm going to substitute in -4. And for B, I'm going to substitute 5. Once you've made the substitution, all you do is what you did on the last problems, order of operations. So pause the video now and see what you come up with as your answer using your order of operations. Hopefully you got 7 just like I did. If you didn't, see if you can rework it and see if you can figure out, compare your work to mine to see where you made your mistake. So pause the video if you need to, and then restart the video when you're ready. Alright, example 2. It is same thing. We're taking our expression, and let's see, everywhere we have an A, we're putting a parentheses, and everywhere we have a B, we're putting a parentheses. And I'm going to color code these. My A is going to be red, my B is going to be blue, and finally, let's see, my C, I'll make it green. So my C is green. Now all I'm going to do is substitute those values in. I'm putting in 7 for A and 3 for B. Whoops, and I forgot to put my cube on the 3, so I'm going to go ahead and add that right there. And let's see what else we have. I need to put my 5 in for C. So there goes my 5. Now what I want you to do is I want you to pause the video to see if you can use your order of operations. So pause the video now. Alright, did you get 162 for your answer? If you didn't, you should go back and check your work and compare your work to mine. Now we're ready to, if you got that correct, we're ready to go on. Alright, now I have one for you to try on your own. You go ahead and do everything this time. Put the substitution in for X, the substitution in for Y, and simplify. So pause the video now and give that a try. Alright, my answer was 18. Was yours? If not, go back and compare your work with mine. Otherwise, if you got 18, great job, and we're ready to go on. Okay, our last topic here. We're going to simplify algebraic expressions by combining like terms. Remember from your definition, like terms have the same variable and the same exponent. So let's look at our two examples here. In the first one, I have a 7x squared. The x squared is the key thing here. And if I look here, I have a negative 4x squared. They both have an x squared. Your x is your base, your 2 is your exponent. They have the same base and the same exponent. When you have like terms, what makes them the same, which is that x squared, has to stay the same. That cannot change. So you rewrite that x squared and you do your math with the numbers in front. 7 minus 4 is 3. Alright, our next term, it has a y squared. And if you'll notice right here, this term right here has a y squared also. So they are like terms because they both have a y squared. So what makes them the same, the y squared, stays the same, y squared. And you do the math with the numbers in front. 3 plus 2 is 5. So there's your expression simplified. Alright, now, as always, in everything in math, it builds upon everything. So we have an extra step added in here before we solve this. We have parentheses, grouping symbols, and we have to get rid of the negative. So I have to distribute the negative to everything inside. It's like multiplying everything by -1. What that does is you keep the 3k, you keep the m, and you flip the signs. I also have a grouping symbol in this second set of terms here, and it has a 2 out in front, so I have got to distribute the 2 to everything inside. So 2 times k is 2k, and 2 times -4 is -8, and there's an m attached to it. Now look to see if I can simplify. So first of all, this term has a k. This term has a k. So they are like terms. So I can combine them together. What makes them the same, the k's, stays the same. And I do the math with the numbers in front. So -3 plus 2 is a -1. Or I can just do a -k. Finally, I got a term with an m. And I have a term with an m here. M's are what makes them the same. So what makes them the same? What makes them the same stays the same. So I rewrite my m and I do the math with the numbers in front. -m, that means -1m minus 8. That gives me a -9m. So, let me write this a little bit better here. This is what our answer looks like. -k minus 9m. Alright, last slide. Woohoo, right? We're almost done. So what I want you to do is you're just combining like terms. I want you to see if you can do these problems and combine and simplify your like terms on your own. So I want you to do both of the problems. So pause the video and do both problems, then restart. So pause the video now and do both problems. Alright, here's my answers. When comparing mine with yours, I hope they were the same. If they're not, go back and check your work. And I've color-coded the like terms and circled them so that you can tell what you can combine and put together. And that's all we have for evaluating algebraic expressions.